I believe. I mean, I don't know if that's the word they want you to use here. I suppose you could say expand the radius by a factor of 4, but to address it, you either need to say dilate it by a factor of 4, and I'm not sure it's a dilation, but I think it is. In other words, once we move that circle to there, to turn that little circle into the big circle, we just dilate it, I guess.
Yeah.
I don't know. I was always a little fuzzy on the dilation thing. But I think that you would dilate it. I think that's the word you would use. Is circle A similar to circle B? The answer is yes, and the explanation is all circles are similar to each other. There is no circle that is not similar to another circle.
Okay.
In other words, that's what makes circle the perfect shape in the universe.
Yeah.
Is that they're all similar to one another, as opposed to triangles.
Yeah.
Alright, the equation of a circle, that's what are the center and the radius. So let's talk about the general format for the equation of a circle.
Okay.
It is x minus h squared plus y minus k squared equals the radius squared.
What's the h and the k?
That's the center. That's the coordinates of the center.
Okay.
So if we bring up your problem, so if this is the general format and we're looking at this, where's the center? What's h?
H is -4.
A negative. Remember this, the general format is x minus h.
Oh yeah, so +4?
Yes. So x coordinate is 4. What's the y coordinate?
+1?
No, again, it's got to be -1.
Oh yeah,
if it was x, it's y minus a -1, which turns into y plus 1. So when you see y plus 1, you basically want to take the opposite sign of whatever that number is, or whatever is there. So it's -1. And put this in the format that I've written it. So what do you have to do with that?
Okay, so you have to...
What do you do?
You go...
-81.
Yeah, which is the radius.
Well, you need to move it to the other side of the equation. In other words, add it to both sides of the equation. So we'd end up with 81 on the right side, and that's the radius squared.
Okay.
You got it, 9. But it's not -9.
It's not?
No. In other words, if I complete this equation, it's x minus 4 squared plus y plus 1 squared. I'm going to move the 81 to the other side so it becomes positive.
Okay.
Well, that's r squared. What is r? 9. Now, r could be plus or minus 9, but when you're dealing with geometry, you always throw out the negative if it's a measurement.
Okay.
So the only r that works is plus 9. There's no such thing as a radius of -9. Okay? Just like there's no such measurement of the side of a rectangle of -5. You cannot have negative measurements. So whenever you come up with a negative, be leery. It can't be negative. I mean, algebraically it could be, because r squared equals 81 means r equals plus or minus 9. But you got to throw out the 9, the -9 part.
Okay.
Okay, let's look at if the endpoints of the diameter are minus 5 and 0, which is right there. Ah, the other endpoint is up there. So it's not centered at the origin.
Okay.
Right?
Yeah.
In other words, the circle I should have drawn, here's one point of the diameter, there's another point of the diameter. Well, the circle has to go about that diameter.
Yeah.
Okay? So that's not a circle at the origin.
Okay.
So this isn't going to work because this 0 and 0 indicates that the center is at the origin. Well, we can see that the center is there. Question is, where is that? In other words, there's minus 5 comma 0. There's 0 comma 5. What do we want? We want the midpoint, don't we?
Yeah.
What's the midpoint?
The midpoint is 5.
What's halfway between 0 and minus 5?
Yeah, okay, so negative 2.5?
What's the y coordinate?
2.5?
Okay. Now, does that make sense looking at it?
Yeah.
It does. Okay. That's always a good thing to do, is to check it, make sure we got the right signs everywhere. So the equation of that circle is what?
Okay, the equation is x minus, is it 2.5?
Minus a minus 2.5.
Minus 2.5 squared.
X plus 2.5. I just wrote it like that just to show you how you get that.
Okay. And then you have to square that.
Yeah, in other words, this is, h has to be minus 2.5, and it's x minus h, so it's x minus a minus. So it becomes plus. And then what's the y part?
Is a y minus a minus 2.5 again?
No, this y is positive.
Oh, okay, so
Y minus the positive 2.5.
yeah, squared.
And what's the radius of the circle?
5?
If it's 5 from here to here, and 5 from there to there, what's the length of that hypotenuse?
I have no idea.
Well, use the Pythagorean Theorem. We have a triangle
Okay.
that has sides of 5 and 5. How do you figure out the hypotenuse?
A squared plus b squared.
Equals c squared. So c is equal to... Remember that when you're solving a right triangle, no matter which side you're solving for, the answer always begins square root of something.
Okay.
So this is going to be the square root of what?
Of 25.
Plus 25.
Plus 25.
Square root of the sum of the sides. In other words, c is, if c squared equals a squared plus b squared, then c equals the square root of a squared plus b squared.
Okay.
Well, a is 5, b is 5. The square root of 25 plus 25, or the square root of 50.
Okay.
Now, normally we would have to reduce that because it's not simplified. That's what r is.
Yeah.
But we don't need r. We need r squared.
Okay.
So what's r squared?
Is it?
If r is square root of 50, what's r squared?
50?
Uh-huh. So all we're doing is squaring both sides.
Okay.
In other words, if r is square root of 50, I'm going to square both sides. That side squared is r squared. This side is 50. Square root of 50 times square root of 50 is 50. So we've got r squared. We never needed r. But we didn't need r squared. So Can you always inscribe a quadrilateral in a circle?
No.
Actually, I think you can. That's a good question. Why? Well, can I draw any kind of quadrilateral that I want?
Maybe.
No, I can draw an awful lot of them. I can draw a strange looking one like that. I could draw a normal one. Why would it be that all quadrilaterals can be inscribed in a circle? Well, your answer actually is right.
No.
Some of the angles in the quadrilateral equal 360, and each quadrilateral corner subtends an arc.
Okay.
This corner subtends this arc. This corner subtends the rest of it. When you have two chords intersecting on the circumference of a circle, this measurement of this arc is twice the measurement of that angle. So this corner and this corner, which add to 180, they're always supplementary. When it's inscribed in a circle, they are.
Okay.
Yeah. Interesting. They're always supplementary. So if I make a quadrilateral where they're not, this one I can inscribe in the circle because opposite angles are supplementary. And that's one of the theories of an inscribed quadrilateral in a circle. The opposite angles are supplementary. So I can inscribe this one, and that's all we have to do. We don't have to say, can all quadrilaterals? But it makes me think that they can't be, because all I have to do is make a quadrilateral that does not have the opposite angles. If I make that 90, then surely I could make, hold on, there's a quadrilateral. I cannot inscribe that in a circle. This isn't 90. That's less than 90. That's about 40. And if you think about trying to put a circle on that thing, I wouldn't be able to. Because if the center of the circle would have to be right there, and making the radius right there, well, this distance to there is a lot smaller than the radius, so there's no way that point ends up on the circumference. So the only way a quadrilateral can be inscribed in a circle is if its opposite angles are supplementary. So this isn't really the reason. Close, good idea, but it has to be the opposite angles, not just all.
Okay.
All right, let's go to your second page here. What the heck? We started at 7:30, didn't we? Okay.
Yeah.
Okay. I'm just trying to figure out my schedule. Suppose AB is a diameter and C is a point on the circle. What time a triangle gets inscribed in a semicircle? That's what this is. In other words, the fact that AB is a diameter makes this thing a semicircle. When you inscribe any triangle in a semicircle, this is always a right angle.
Alright,
In other words, it doesn't matter how you draw it. If I have a semicircle and I want to put my triangle like that, that's a right angle. I want to put my triangle like that, that's a right angle. You can't put it in there without it being a right angle.
Okay.
Okay. So what kind of circle or what kind of triangle is this?
I said it was isosceles,
But it's right.
but it's right, yeah.
Okay. So that's all you need to do. In terms of justifying your response, just say that all triangles inscribed in semicircles are right triangles.
Okay.
Given that angle ACB is equal to 2x plus 8, what is the value of x? That angle right there is 2x plus 8. So how do I get x? What is that angle measurement? We just talked about it.
So it's 172?
No.
Oh, 90?
Yeah, it's a right triangle.
Yeah.
That's the angle that's the right angle. Always that.
Okay.
Not ever one of these two. No matter how you draw it, it's always the one that's touching outside. That's the right.
Okay.
So if that's 90, and it's also 2x plus 8, how do I solve that? Give me the equation I need to write.
So 2x plus 8 equals 90.
Next line.
And then you can minus 8. So 2x equals 82. And then divide by 2. 41. Okay. Alright, that's easy.
Yeah. What type of triangles are OC? In other words, if I draw a line from the center to C, I make another little triangle here. Here, let me do it on my paper. So there's their triangle. So they say triangle COB would have to be, I would have to draw that line right there. And then we're talking about that triangle. What kind of triangle is that?
A right triangle?
Does it look like a right triangle?
Kind of.
Well, let me erase that line. This is the right angle.
Yeah.
Can this be 90 degrees?
Yes.
Can you have two 90-degree angles in a triangle?
I don't think so.
No. That totals 180, doesn't leave anything for the third angle. So this has to be less than 90.
Yeah.
Okay, so now let me redraw it. Look at this triangle. What can you determine about it? Let me erase this line. What's true about OB and OC?
OB and OC. They are...
Both radiuses, aren't they?
Yeah.
All radiuses within the same circle are equal.
Okay.
So that has to be equal to that, making it what kind of triangle?
Equilateral?
No, equilateral is all three sides.
Isosceles?
Isosceles. That's all we know. So COB is isosceles. COA, I'm going to have to reconnect that.
Okay.
What kind of triangle is COA?
That one is, I have no idea.
Well, what's the relationship between AO and OC?
Are they both radiuses?
Yeah? So that's also isosceles.
Yeah, okay.
Whenever you have a triangle that has a vertex there and any point there, those are always isosceles triangles because all radiuses are equal within the same circle. Now, if this is 60 degrees, then it's also equilateral, but only if it's 60 degrees. Remember, equilateral means 3 equal sides, 3 equal angles, so they all have to be 60 degrees. That's the only time it would be equilateral, is if it's exactly 60 degrees, and they don't give us any information here to let us know that that might be 60 degrees. So isosceles is all we can say for both COB and COA.
Okay.
Given the measurement of AC is 100, find angle BAC. Okay. This is 100 from here to there. They want this angle right here, BAC or OAC, whatever you want to call it.
Okay.
As in most geometry problems, you always have to solve for something else before you can solve for what you're looking for.
Yeah.
What's the measurement of arc CB?
CB?
CB.
I think.
What's the measurement?
Maybe it's like.
What's the measurement from A all around to B?
180.
Okay. So what's the measurement from C to B if from A to C is 100?
80.
Okay. Now, you have a situation in geometry where if you have two chords intersect like that, and this is 80, what's this angle down here?
It's
half of that.
Half of that. Yeah.
The way to memorize that is let's look at it on a larger scale here. First thing to memorize that they teach you is that that theta equals that theta, right? If your angle comes from the center of the circle, then if that's 70 degrees, that's 70 degrees. Okay? If the vertex of that angle is on the circumference, well, clearly it's not as big an angle. And if you remember that the ratio is either 2 to 1 or 1 to 2, it has to be 1 to 2. Because I can tell that that angle is smaller than that angle. So if there's a 2 to 1 ratio involved in here, it can only be that way. There's no way this can be twice that. But this can certainly be half that, and it is. It's 35 degrees. So in our, what do we keep doing? So in our thing, if this is 80, what's this angle?
Then it's 40.
What's this angle right here?
80.
Correct. Yeah, you need to change that to 40.
Okay.
Because they're talking about this angle down here, not that, not that arc length. In other words, make sure you distinguish between angles and arc lengths on these problems. That little curve thing means arc length. The angle means measurement of angle. All right. So let's look at 6. Okay. You measure arcs in 2 different ways. You can measure an arc with degrees, like we've been doing, but there's also an absolute distance, right?
Yeah.
In other words, if I talk about a circle, the measurement of the arc length is the circumference. If I want the measurement of that entire arc length, so if I have a circle of radius 3, the measurement of that arc is 2 pi r, or 6 pi.
Okay.
Okay? So the measurement of the entire arc here would be what? In other words, forget the fact that they've taken this angle out here. Let's just look at that whole circle. What would the measurement of the entire circumference of that circle be?
360?
Circumference. What's the general formula for circumference?
Pi r squared.
It's area.
A equals pi r squared. Okay.
Remember, it's the same 3 numbers, they're just in different order.
R, 2 pi r. Okay.
These are 2 formulas you want to know like you know your name.
Okay.
Okay? There's no formulas in geometry more important than these 2 right here.
Okay.
You're going to instantly be able to say each one of them. You don't have to think about it at all. So, if I'm looking for the circumference of that whole circle, what is it?
So, is the radius is 11 feet?
So it would.
So 11, 22, 22 pi.
2 pi would be the entire circumference. Well, what part of the circumference are we looking at when we look at DOG? What ratio of the full circumference do you think that is?
1/3?
Well, it's a lot more than 1/3. It's all the way. It's almost the whole thing.
Okay.
How would we figure it out? They give us this 315 here. If the whole circle is 360, right?
Yeah.
So we want
360 minus 50.
no, not minus. We want that ratio. In other words, this is the ratio of our arc to the circumference. Well, the circumference is 22 pi. So if I want the measurement of our arc, I'm going to multiply it by 22 pi.
Okay.
We have this part of that total circumference. If this was 180, we would be looking at half the circumference, and it would just be 11 pi. But it's not 180, it's a weird number like 315, but the ratio of this arc to the circumference is the same ratio as 315 is to 360.
Yeah.
So we multiply the entire circumference by that ratio.
Okay.
Same if they asked for area of this thing. They wanted the area of that thing. Well, first of all, I would take the area of the entire circle, which is 121 pi r squared. And then I would take 315 divided by 360 times 121 pi. And that would give you the area of that whole thing there.
Okay.
Oh, and that's what 7 asks for, is the area of that sector.
Okay.
So we don't need to do the arithmetic. You've got a calculator, right? You can come up with these.
Oh, yeah.
Make sure your answer is in pi, not in a number.
Okay.
In other words, is all you want to do is do this part of it and then add pi to your answer. Same thing over here. You're at a point now where you should never be converting pi to a number.
Okay.
Just leave it as pi. Same thing with
All right.
radicals. Maybe not radicals yet. Not quite there in radicals. Okay. So we have our master question, number 8. Let me get it so that I can see it. I think I'm going to have to draw this. That's merely the points of tangency.
Okay.
It's the point where those chords connect. And I don't know what I is. I guess I is the measurement of that arc. I don't know why they... Oh, that's the point of tangency of the circle right there. All right. So what do they give us? They give us that P is 16. They give us the measurement of CO is 96 degrees. Find each indicated measurement. OAC, this angle right there. What is OAC? If I draw just part of this,
Okay. Huh.
there's A, there's O, there's C, that's 96 degrees. What's that angle?
Half, right?
Huh?
So 96 divided by 2 is 46, I think.
48.
48?
48 plus 48 is 96.
Yeah.
So that should be 48.
Okay.
MOA. MOA. This angle right here. We'll call it X. In my drawing. Thinking. So if I draw this circle without anything and just the MOA, it looks like this. So if I want to know this angle, I need to know that arc, right? In other words, if I want to know X,
Okay.
it would be useful to know the arc length from M to A.
Yeah.
Well, we have a formula for doing it.
Okay.
going to have to look it up. I don't know why I do not memorize these formulas for circles very well, because this, you don't need to know this for the ACT. Circles are chapter 7? No.
I don't know.
Circles must be chapter 9.
Okay.
Hold on, let me check the chapter. No, that's right, triangles. What are circles? Hold on. Circles are chapter 10. Alright, when you have chords that intersect outside of the circle, which is what we're looking at here.
Yeah.
In other words, if you look at this top diagram over here, PO and PC are chords that intersect outside the circle at P. Well, there's a formula that says first of all, oh no, excuse me, hold on. I've got to get the right formula. Here's the formula. When I have the following situation. I've got a chord, and I know that that's 96 degrees.
Okay.
Question is, and I also know this angle is 16. Well, there's a formula that says the measurement of angle 3, this small angle, the measurement of 16 degrees is equal to 1/2 of the big arc, 96, minus the smaller arc, which we'll label X.
Okay.
Okay? So 16 has to be equal to 1/2 of 96 minus X. In other words, you take the difference of the large arc minus the smaller arc, half of that, and you get this angle.
Okay.
Okay, so what does that have to be? Solve that equation.
Okay. So
What's the first step to solve it?
multiplying the parentheses.
Nah, let's multiply everything by 2 and eliminate the parentheses that way.
Okay.
Doesn't that make it easier?
Yeah.
In other words, the sooner you can get rid of fractions, the better. Turned
Okay.
it into a problem that's all big numbers.
Yeah.
So what's X equal to?
So would it be easier to plus X?
That's what I did. I added X to both sides, which means I got to subtract 32 from both sides.
Okay, so that's 64, yeah.
Okay? So that is the measurement of that arc. That's all we've determined so far. That is 64. Right?
Yeah.
What's X?
X equals 32.
You got it. So MOA is 32.
Okay.
The measurement of AM, they got these out of order. This shouldn't that have been B? Because we had to solve for that in order to find MOA.
Yeah.
Well, we
So,
just solved for AM arc,
yeah,
64.
yeah.
And finally, D is CNO.
Okay.
Thinking. CNO. Now, let's see. Let me label everything we've determined here. What was X? X was 32?
Yeah.
So that's 32. The first question was OAC. On OAC, we came up with 48. And arc length was 64. So that's 64 length right there. And they want this angle there, CNO.
Okay. CNO. Okay.
I'm trying to figure out how to do it. I'm not sure I know. Ah, I just figured it out. What's this angle right here that I just circled?
Which angle? Right there?
Yeah, this one right here.
Okay.
That subtends that arc.
Okay.
That's going from the edge of the circle. 2 chords. Got to be half of that. It's got to be 48 also.
Yeah.
Well, now we can figure out everything. Once you know 2 angles of a triangle, what's this angle? If that's 48, that's 32. What's this one?
So that equals 40, 50,
48.
80, 100.
Okay. If that's 100, what's this one? Their vertical angle?
That's 100 too.
80.
80.
In other words, if this is 100, they're always supplementary. That's a
Okay.
straight line. So you got 100 there and 80 there.
Okay.
Okay? I think that takes care of it. That covers a
Yeah.
lot of geometry.
Yeah.
That chapter is one of the harder chapters, and the reason I don't have it memorized down pat is because you don't need this stuff for the SAT or the ACT test. You need it for geometry class.
Yeah.
You don't need to carry it forth. You won't need it again after you're done with geometry.
Okay.
No point where they're going to ask you these formulas again.
Alright.
Unfortunately, every geometry student has to go through all of these. So
Yeah.
the only thing I can suggest is you do your best to memorize them.
Yeah.
Memorize stuff like x is always half of that, and that this is always equal to half of the difference between that and that. Stuff like that. You really just, you know what you should do is go through your book. I believe we have the same book. And you know all of the green theorems?
Yeah.
Just look at each one of them and memorize the formulas that are in each one. And some of these chapters have like 8 of them. So there's a lot to memorize. But you're at a point in geometry now where it's pretty much all memorization.
Yeah.
You can solve for everything if you remember the general formula. But you got to remember that.
Okay.
Okay? And the best way to do it is the way I kind of do it when I don't have them memorized is I go to the chapter on circles and I start looking for green theorems. All the formulas that I'm looking for, they're going to be under a green theorem. You know what I mean by the green theorem boxes?
Yeah, I see.
Just go through, find every one of them in this chapter, and make sure you have it memorized.
Okay.
And then you can solve all of these kind of problems. Once you have them memorized, that's all there is to it. The rest is just arithmetic. But you got to know those theorems.
Okay.
All right? Anything else?
No, I don't think so.
All right. Have a good week.
Okay, you too.
Julian. Bye-bye.
All right, thank you.
Yeah, you're